In this video we're going to look at using trigonometry to find an angle. When finding an unknown angle, the inverse trig function must be applied. So that's sine to the minus 1, cos to the minus 1, tan to the minus 1. And that's the shift button on your calculator and then the sine, cos and tan buttons. We use a similar method as we did before if we're trying to find the angle. So we'll still draw the triangle. We'll label the sides. We'll write out SOHCAHTOA, and then we'll choose the appropriate ratio. The only difference then is what we'll have is, for instance, we'll have sine theta equals 4 over 5, and then rather than dividing by a sign, we use this shift sign, or the second function of sine, and we'd write it as theta equals sine to the minus 1 of 4 over 5, or cos to the minus 1, or tan to the minus 1. So it's a very similar method as before, only this time we're kind of dividing through by the trig ratio, but rather than dividing we do this trig function to the power of minus 1. So in example 11 then we need to use our calculator to work out the following. So part A, if we know that sine theta equals 1, to work out theta we do sine to the minus 1. So by moving the sine part to the other side of the equation, it turns into sine to the minus 1. So then we'll have theta equals sine to the minus 1 of 1, and if we put that into our calculator we should get an answer of 90 degrees. For B, we've got tan theta equals 0.124. So then theta is going to be tan to the minus 1 of 0.124. And putting that into your calculator, we get an answer of 7.069 degrees. And part C, again, we've got cos theta equals 1 over 3. What you kind of want to be thinking about is, well, let's divide through by cos. But we can't divide through by cos, we have to use the inverse. So then we'll have theta equals cos to the minus 1 of a third. And putting that into your calculator, we get 70.53 degrees. Example 12, find the angle in the diagram below. Give your answers correct to 3 significant figures. So we've got our triangle. The first thing we need to do is label the sides. So 18 is the hypotenuse. The angle marked, the side opposite is going to be the opposite, and then the side beside it is the adjacent. Then write out SOHCAHTOA. And we can see that we're not interested, or we don't have any information about the opposite. So I'm going to score out SO because it's got an O, and TOA because it's got an O. So now we're left with CA. So CA is cos of theta equals A over H. Filling in the information we have, theta is our unknown, A is 15 and H is 18, so we've got the cos of theta equals 15 over 18. Again, what you would kind of want to do is divide through by a cos, but we can't do that. We apply the inverse cos, so then we have theta equals cos to the minus 1 of 15 over 18. Putting that into our calculator we get 33.557 or 33.6 degrees to 3 significant figures. In triangle ABC, B is 90 degrees, BC is 12 and AB is 16. Find angle A and C. So the first thing we need to do is draw a right angle triangle, and we're going to label the right angle as angle B, and then the other 2 sides as A and C. BC is 12, so that's the length joining those 2 vertices, and AB is 16. First of all, we want to find angle A, so let's call that our theta first of all. So we've drawn our triangle, now we need to label the sides. AC is the hypotenuse, and BC is the opposite, and AB is the adjacent. So we've got SO, CA and TOA. We don't know anything about the hypotenuse, so we can get rid of SO and we can get rid of CA, and we're left with TOA. TOA then is tan of theta equals O over A. So tan theta must equal 12 over 16. We would instinctively want to divide by the tan, but since we can't do that, we do tan to the minus 1. So theta is tan to the minus 1 of 12 over 16. So theta is 36.9 degrees. So A hat is 36.9. To work out angle C, well, we know the angles in a triangle add up to 180. So A plus B plus C is 180. We have 36.9 plus 90 plus C equals 180. So that means that C must equal 53.1 degrees. Example 14, a line joins the point 0, 0 and 5, 7. Find the angle it makes with the vertical. So what we'll do is we'll sketch out our set of axes. And we've got the points 0, 0 and 5, 7. So that'll be across 5 and up 7. And the line will join those 2 points. What we've got then, we could draw a line to the vertical, or to the horizontal even, sorry. And now we've got a right angle triangle. And we know the base length is 5 and the height is 7. And we're trying to find the angle that the line makes with the vertical, so that's with the up and down direction. So that's going to be the angle up in here. So we've got the triangle drawn. We need to label the sides. So we're looking for the base, or the base side is the opposite. The diagonal is the hypotenuse, and the vertical distance is the adjacent. We write out SOHCAHTOA. And we can see we don't need the hypotenuse, so we need to get rid of SO and get rid of CA. We're left with TOA. So TOA is the tan of theta, as the opposite over the adjacent. So tan theta is 5 over 7. Theta is tan to the minus 1 of 5 over 7. And theta is 35.54 degrees. Example 15, a man walks 10 kilometres due north, then 7 kilometres due east. What bearing should he walk along to get to where he is if he should have taken a direct route? Now this mentions bearings, and bearings are always measured from a north line. They're measured in a clockwise direction, and they must have 3 figures. So if we were dealing with this distance and that angle measured to be 40 degrees, the bearing would be 040 degrees. If we were trying to get this angle here, so let's say that's 35, because we've got our north line, we're actually looking for the angle outside of that, so that'd be 325 degrees. So bearings are always measured from a north line in a clockwise direction and must contain 3 figures. So what we have is a man walked 10 kilometres due north. So there's 10 kilometres, and then 7 kilometres due east. And that means that those 2 distances are perpendicular. And we're trying to find, had he walked on the straight line, the bearing. So this would be our north line. So we're looking for this angle in here. We've got a right angle triangle. We need to label the sides. We're looking for the bottom angle. So then the 7 is the opposite. The diagonal line is the hypotenuse, and the 10 is the adjacent. So write out our SOHCAHTOA. We don't care about the hypotenuse, so we can get rid of SO and CA. We're left with TOA, which is tan of theta. It's O over A. Tan theta then is going to be 7 over 10. Theta, so we can't divide by tan, we do the inverse tan, so tan to the minus 1 of 7 over 10. And using our calculator, we do the second function, or the shift of tan, 7 over 10, we get 34.99 degrees. So the bearing then that the man would have had to have walked on would be 0, 3, 5 degrees, rounding to the nearest degree.